Like and subscribe. Let's get to it. Earlier this week, I had the chance to run a Claisen rearrangement for the very first time. So the reaction that I did used a scaffold very similar to what I have drawn here. And what happens is you add a ton of heat to this compound to get a sigmatropic rearrangement that looks like this. So to show you how this happens, what I'm going to do is redraw the starting material so that it looks like there is another ring about to form. So in this reaction, it's concerted where you'll have 3 arrows, one going to the ring, one up to the oxygen, and then one breaking the carbon-oxygen bond. And then you get an intermediate that looks like this. Oxygen double bond now, with your newly formed alkene. But we know that there's going to be a tautomerization to reestablish aromaticity, so equilibrium is going to favor the aromatic phenol. This reaction happened at 190 degrees Celsius. So I wondered how much pressure could possibly build up in my reaction flask or my bomb. So I used PV equals nRT. And mainly, we're going to switch this around so that P is equal to nRT over V. So now starting with N, I know that I have 2.5 milliliters of toluene in my reaction flask. I'm going to multiply that by the density, which is 0.87 grams per milliliter. And then I'm going to divide that entire thing by its molecular weight, 92.14, and that's going to give me 0.0236 moles of toluene. So now R, in this case, is going to be 0.082, and the units for that are liters times atmosphere, ATM, times inverse K, times inverse mole. Temperature is going to be equal to 273.15. So negative 273.15 is absolute zero. And then so 0 degrees Celsius is positive 273.15 Kelvin. Plus 190 degrees Celsius is going to give us 463.15 degrees Kelvin, which is pretty crazy. And then finally, the volume is going to be 0.015 liters. So now to put this all together, P is going to be equal to 0.0236 times 0.082 times 463.15, all divided by 0.15. And that comes out to just slightly above 60 times atmospheric pressure, which is pretty crazy if you think about it. That's why when we run reactions in a bomb like this, we set up a blast shield around it. Hope you enjoyed this video. Let me know what you think in the comments, and I hope you like and subscribe, and I'll see you next time.